As we age, our skeletal muscle mass declines, which in turn increases our risk of physical disability. To discuss his recent research on dietary interventions for optimizing protein and leucine intake is Dr. Daniel Traylor from Adrian College. Daniel, it's great to have you here. Thank you very much for taking the time.
Yeah, thank you, Alistair. Thanks for having me.
Daniel, just to reiterate, why is leucine such an important ingredient for stimulating muscle protein synthesis?
Yeah, leucine, the research behind leucine spans back, give it at least 20 plus years. More recently, if we kind of talk about what do we know as far as about leucine's effects in human metabolism. Well, what we know now is that of all the essential amino acids, leucine appears to be the most potent at activating the anabolic signaling for muscle protein synthesis. You might hear that also as muscle protein growth. So how fast, the rate of growth in muscle contractile proteins, right? Which makes up our body mass, predominantly roughly 45%, maybe 50% of our body mass is our skeletal muscle. So of all these essential amino acids, leucine tends to be the one that gets the muscle protein synthetic machinery activated. Now, that being said, all the other essential amino acids are required to support this leucine-driven increase in muscle protein growth or muscle protein synthesis. So just to kind of give you very briefly, a little bit about the mechanistic underpinnings of leucine and its effect on human physiology. A lot of this research, groundbreaking research more recently, came out of David Sabatini's lab at the Massachusetts Institute of Technology, MIT. Lead researcher on that, her name was Rachel Wolfson. And that paper came out in 2016, and it was describing particular protein, which was they call it an evolutionary conserved protein. This protein is called cestrin-2. And it was found that cestrin-2 is a leucine sensor for the activation of our major growth control pathway, which is known as mTOR. I know it's a mTOR. What does these acronyms stand for? But that stands for mammalian target of rapamycin complex 1. And this is a master growth controller pathway. And if we kind of just keep this specific to skeletal muscle, what leucine does is it binds to cestrin-2. And this binding causes a signal transduction pathway that allows this mTOR complex 1 protein, this master control growth controller protein, to translocate to another organelle in our cell called the lysosome. And it interacts at the membrane of the lysosome, and this is where mTOR complex 1 becomes activated. So when that becomes activated, there's a subsequent initiation of muscle protein synthesis or muscle protein growth. So I know that was a lot. That's sort of what we know on the mechanistic underpinning side. And so if you want to kind of think of this in a metaphoric terminology, you could consider, and Stuart Phillips says this elegantly, you could consider leucine as being jet fuel to gasoline. Okay, so that I know this. I've never heard it put that way before, but it is sort of true. And what the research is showing, particularly as we age, is that we have this kind of resistance to dietary protein, including leucine, to the effects of dietary protein, these anabolic or growing effects, particularly to the skeletal muscle. And so we think that there may be this particular trigger. It's been hypothesized as the leucine trigger. A certain threshold must be met as far as leucine concentration in circulation, saying after eating a meal, in order to robustly stimulate the growth pathway or muscle protein synthesis. So that's sort of what we know right now about that particular amino acid, leucine, which is one of the branch chain amino acids.
Thanks a lot. And do you see that the recommended daily allowance then for protein, that should be revised upwards with respect to older people, and you've alluded actually this in your prior publications, but can you maybe share a bit more on that?
Yes, yeah, no, that's a really good point. And at least from, say, the scientific community, we would, many researchers are alluding to the fact that the recommended dietary allowance is too low, particularly for older individuals. So to unpack that a little bit more, we can consider a few major points, say, in society, what's going on. So at least what we know in North America, by around 2050, roughly between 20 to perhaps upwards to 30% of the population is going to be over the age of 65 years old. So that's a dramatic rise in older individuals. And sort of to define what sarcopenia it means, that is sarco meaning Greek for flesh, penia lack of. So a deleterious or dramatic loss in skeletal muscle mass as we age. And that is a result of the aging process. There's several hypotheses out why we get older. There's really only two ways that cells die. That's through necrosis, or that's through cellular apoptosis. So what we know is in healthy aging individuals, by around the fourth decade of life, we tend to become more resistant to the anabolic effects of dietary protein and amino acids. And seeing that our society by 2050 in the near future is going to be a vast, large amount of people, not just in the that are over 65 years old, not just in North America, but also around the world. This is a concern. So reports came out in the early 2000s, and around 2004, there was a report by Janssen that indicated that the healthcare expenditure rate for the annual healthcare expenditure rate was roughly $20 billion, which was attributed to services for treating sarcopenia. In the US, that accounted for about 1.5% of the healthcare expenditure. So we know that this is an issue, at least from a monetary standpoint, but also from a health standpoint, trying to keep individuals healthy throughout their lifespan and avoid disability. This is sort of the idea of why do you want to maintain your muscle mass across the lifespan? Well, after a point of losing muscle mass, which is roughly can be roughly 1% muscle mass loss per year, particularly when someone's in this stage of anabolic resistance, the chances of having a disability or falling below a threshold, the disability threshold, those chances go up, they increase, right? And that leads to people having problems just with daily activities of living. So the idea is to try to maintain muscle mass to a point where the individual does not fall below this sort of quote unquote disability threshold. So do we see in the future, in the near future, the recommendations, and we'll speak about the recommendations that are set forth by the Food and Nutrition Board here in the US, which doesn't alter too much as far as the recommendations given in North America compared to other countries. It's not that much of a difference. Currently, right now, the recommended dietary allowance of protein is 0.8 grams of protein per kilogram of body weight per day. What the scientific community is explaining to these government agencies is that that's too low, and that level should increase perhaps to 1.2 grams of protein per day, grams of protein per kilogram of body weight per day. Now, if we keep going and keep further unpacking, that will say the government at least make alterations or make establishments that protein intake should be increased. Well, first, let's understand, how did this recommendation come about? First, the recommended dietary allowance, again, which is 0.8 grams of protein per kilogram of body weight per day, that was set forth based on a paper that was by William Rand in 2003. Okay, this was a meta-analysis of all of the available nitrogen balance studies. So nitrogen balance is a technique that it examines the balance between nitrogen intake and nitrogen loss. And that's done by collecting, say, urine, feces, skin, hair, nails, exhaled ammonia. And keep in mind, we're talking about nitrogen here because nitrogen is an element that's a component of a protein. So if we kind of remember our biochemistry, proteins are made up of amino acids, and amino acids contain nitrogen. And nitrogen is, we can measure that through what I just described, through collecting these kind of samples. So if you're able to collect these samples over a certain amount of time, and typically these nitrogen balance studies last about a week, maybe 2 weeks, the way that this method works is that an individual will be given at least 3 different protein or nitrogen intakes. And then from there, a zero nitrogen balance will then be interpolated. So if you can imagine on an x-axis, increasing protein amounts, and then on the y-axis, you have net protein balance, you'd see a direct relationship or a direct increase as far as nitrogen balance to a point. And then that point is no longer linear, but it becomes flat or horizontal. It plateaus. And where that plateau occurs, we can interpolate down to the x-axis and see that at that level of protein was the maximum amount of protein needed to maintain nitrogen balance. Okay, so that was a whole lot right there, but the RDA is based on this meta-analysis on nitrogen balance. Now, the results of that came out to be a nitrogen balance of, say, an estimated average requirement. So where that break point occurred, as far as that linear increase until we see this plateau and the individuals have reached nitrogen balance, if you interpolate down, on average, that amount of protein needed to maintain nitrogen balance was 0.66 grams of protein per kilogram of body weight per day. Okay, so that was the minimum, that was the amount needed to maintain nitrogen balance. The recommended dietary allowance was considered to be 2 standard deviations beyond the estimated average requirement. And that number came out to be 0.8 grams of protein per kilogram of body weight per day. So that is where the US government set the requirements for everyone in North America to consume at least 0.8 grams of protein per kilogram of body weight per day to maintain nitrogen balance. But the RDA does not take into account differences between the sexes, and it does not take into account age or age groups. So that is where the scientific community has come in and said that this nitrogen balance technique is not sensitive enough to determine, or is not high enough to help an older person that is anabolic resistant or is going through anabolic resistance, has been now shown clinically to be sarcopenic. This level, what the scientific community is saying, and these are based on other methods for determining nitrogen balance, and particularly determining muscle protein synthesis. The growth rate are showing that that level 0.8 is too low. So that is where we are at, and what the governments have, what the FMB has said, the Food Nutrition Board, which is of the Institutes of Medicine, acknowledges that the level of protein perhaps is too low. However, they've defined an acceptable macronutrient distribution range, and they say that in this range, there is no, say, for instance, upper tolerable limit for protein intakes, that they say we describe it in this range. That's about where, as far as a government agency coming out and making any particular changes to policy, that's what has been stated, as well as the CDC, the Centers of Disease Control, has as well stated that the RDA is too low, particularly for older individuals. Will there be a change to the recommendation anytime soon? It's hard to say. I'm more on the scientific side of policies, so we'll see. But it's becoming more apparent that the recommended dietary allowance is too low, particularly for individuals that are going through sarcopenia and older in age.
So one way to increase protein intake could be through, protein bars. What role do you envisage for example, a leucine-enriched protein bar in supplementing the protein deficient meals of older people in future studies or in real-world settings?
Yeah, so this idea of leucine-enriched protein in real-world settings, I think it definitely has applicability as far as helping particular individuals that are going through sarcopenia. Now, how this real-world setting come about, I think of in a real-world setting, when we get older, our bodies tend to go through this process of anabolic resistance. So what does that mean? It doesn't mean that the skeletal muscle does not still possess the capacity to maximally grow, say, at a rate the same as a younger individual. What it means is that in order for that reaction to occur, that robust stimulation of muscle protein synthesis or muscle growth to occur, the individual in older age must consume more protein per meal. And what we know that what that number appears to be on average is about 0.4 grams of protein per meal to robustly stimulate muscle protein synthesis in older individuals. In younger individuals, it's been shown to be closer to around 0.24 grams of protein per meal. So what that means is there's been essentially a rightward shift in the muscle protein synthetic response. So it indicates that as you get older, you're not incapable of maximally stimulating growth rates as you would be at a younger age. It just means that you have to consume more protein. Now, is that feasible? That may not be feasible for many individuals for a multitude of reasons. That range, say around 0.4 grams of protein per kilogram of body weight per meal, that could range up to say 40 or 50 grams of protein for an individual. That might not be feasible. So what can we do to mitigate that situation in order to make a viable product? Because at the end of the day, the consumer who's concerned about their health, if this even becomes, say, more on a public sector in hospitals, it has to be applicable. The patient or the consumer must be able to consume this product. So where the paper that was published that I worked on, in full disclosure, that those studies were coming out of McMaster University, where I did my postdoctoral fellowship with Stuart Phillips. A lot of the leucine-enriched studies are showing that you're able to make a formulation that's containing suboptimal amounts of protein. Lower amounts of protein enriched with leucine can stimulate muscle protein synthesis or muscle growth as if someone ate a large protein containing meal. And so that's what I see from a real world setting, some of these products becoming. Perhaps this suboptimal lower amount of protein enriched with leucine to a point where we know would stimulate muscle growth. So how could these products look? Well, from my experience in food technology, I designed the protein bars for the particular study. I've also designed this type of leucine enriched products for chips. Stuart Phillips is working on suboptimal amounts and different type of powder forms. There's also other groups. Theo Espaglu at Leeds Beckett is using a leucine enriched gel formulation. Different delivery systems, different protein delivery systems, gummy systems. So I see in real world situations, these enhanced product delivery systems for leucine enriched proteins looks to be the future for as far as product development, actually getting the amount of leucine needed into the body so the muscle will grow. Now, as well, there's other what we can say metabolic agents that are that may help in a help further or further enhance the protein formulation. So there's a lot of future in that. I know there's some groups at Maastricht University, Luc Van Loon's group. They've worked on leucine enriched whey protein product with the enhancement with vitamin D. That has shown to be a promising product. There's also Keith Barr at University of California, Davis. He's been working on a collagen or an amino acid enriched collagen product that would stimulate collagen growth. Because remember, the skeletal muscle is not just the contractile proteins, also in between those contractile proteins is connective tissue or collagen, which sort of goes through the same type of deleterious reduction in the stimulation of, say, collagen protein synthesis and muscle protein synthesis. So overall, to maintain a healthy muscle, the collagen also needs to be maintained. And so that's where I'm seeing the future of these type of products going, different metabolic agents being used with this leucine enriched, say, suboptimal protein doses in these more real world situations. And I could further elaborate on that if you like.
That's really interesting, Daniel. Maybe my last question. So these products, do you also see them being used maybe in other settings, for example, in clinical settings where you have populations with compromised appetite, for example, those going through therapy, etc.?
Yeah, no, that's a great question. I do. What we know, at least, say, in more of the clinical settings, say perhaps during critical illness, an individual that is admitted into the hospital and has some sort of critical illness, we know it only takes a matter of days before someone, say, is bedridden, they're laying in bed, they're not moving around much. Skeletal muscle mass will drop, actual function, muscle function will be reduced. There will be a reduced power output by the muscle as well as strength. So we know during these type of events, when an individual has a critical illness, a leucine enriched protein product would dramatically help. Along with, say, it's not just the nutrition side. Say when someone is in a clinical setting, there needs to be these multimodal, say, physical therapies in combination with early, say, enteral consuming some sort of lower energy or hypocaloric energy protein product. All right. A lot of times when someone is in the hospital, the RDA is set at 0.8, even though they're still in a critical illness state. And that exacerbated reduction in muscle mass and muscle function over not much time, the individual they will not be able to consume, say, the optimal amount of protein, that large amount of protein to stimulate muscle growth. And that may even have a life-threatening effect. It's called refeeding syndrome. So in a clinical setting, I do see that these leucine-enriched, say, smaller dose protein products would help an individual in critical illness, as well as long as it's also being used, say, as part of a physical therapy program. Now, what we recently showed with this particular product, this protein bar, and I won't give the story away completely. We ran a follow-up study to the pharmacokinetic study that we discussed. The PK study is at least what we saw with the bar. We saw that levels of amino acids in circulation reached the point, at least to what we know the literature tells us, is that at these leucine concentrations in circulation should robustly stimulate muscle protein synthesis. We saw that the bar increased plasma leucine concentrations to about 590 micromoles in circulation, which according to many muscle protein synthesis studies that have been done and Luc Van Loon's group and Stuart Phillips' group has showed that at that concentration would robustly stimulate muscle protein synthesis. So we saw that with the bar, with the PK study, and our follow-up study we actually did, and that study was actually in older individuals. Average age was just over 70. The follow-up study, which is going to be submitted for publication soon, we did an exercise program. We did a resistance training program, and these were actually in younger adults. We did a resistance training program, and we clamped their protein intake, their diets, we clamped it at 1.3 grams of protein per kilogram of body weight per day, which is just under what we think would be the maximum amount of protein consumed in a day to stimulate protein synthesis, say, in a healthy individual, which is about 1.6 grams of protein per kilogram of body weight per day. We had them at 1.3, so a very high protein dose. And we did a short-term resistance training program. So 4 days of resistance training program. It's a crossover design. The same individuals did the short-term training while they're on this high protein diet, 1.3 grams of protein per kilogram body weight per day. And they did 4 days of resistance training. We took muscle biopsies from their leg muscle, and then we crossed them over, which over a certain period of time, we just washed them out for a few days where they didn't do anything. And they came back and did the exact same resistance training, short-term resistance training program again. However, this time they were consuming the protein bar before and after the exercise program. And what we saw in those results was that muscle protein synthesis was significantly higher due to the consumption of this bar, even though they were at a high protein dose as far as consumption per day, and they were doing resistance training. So, we see that this type of formulation here definitely has promise working in physical therapy, different physical therapy modalities. And being a smaller amount of protein, it's more convenient for an individual to consume than having to consume these large amounts. So that's sort of the latest and greatest coming out, and that paper will come out soon, so I'll shut up about that. Yeah, I think it's really exciting, and there's a definite promise in these leucine enriched products coming out here very shortly.
That's great news. Daniel, thank you so much for all your answers, and the best of luck with your further work at Adrian College. And I hope to hear from you again on your new research very soon.
Absolutely. Alistair, anytime. It was a pleasure. It was a pleasure speaking with you.
Thank you.